Afternoon. Today we're going to start something called the fundamental counting principles. And a lot of you really love guess and check and are very good problem solvers. This is going to help you be even better. So here is our first problem. All three of our examples today are going to be word problems. So bear with me. Actually read through them. Make sure they make sense to you before I get started. So we have Pat's Pizza Palace will prepare pizza with a thin crust, a thick crust, or in a deep dish style. Really nice of them. They give you three options: thin, thick, deep dish. There are also 8 choices of toppings. In how many ways can you order a 1-topping pizza? So a lot of you might want to go ahead and get started and think, okay, if I get a thin crust, technically I could pick from 8 different toppings. So you know that there's 8 different things you could put on a thin crust. So you have 8 options when it comes to thin. With thick crust, again, you have 8 options when it comes to thick. With deep dish, you have 8 more options when it comes to deep dish. So 8 plus 8 plus 8 is 24. Yes, that's the answer. Is there a faster way to get there? Besides thinking through all the options for thin, all the options for thick, all the options for deep dish. Because some of these problems are going to get really big and really complicated, so we have to think of quicker ways to do it. So there were 3 options for crust style. There were 8 choices for toppings. If you multiply all of your options together, because you're kind of trying to figure out how many ways, what are the total number of ways, all of them together. So if you multiply, you'll get all the totals. 3 crusts times 8 toppings is 24 options. This whole multiplying piece is going to be very helpful throughout these next 2 examples. So let's move on to the second one, which is quite a bit more complicated. So we're thinking, how many odd numbers between 10 and 1,000 start and end with the same digit? They have to start with the same digit, end with the same digit, and they must be odd. So I'm going to give you 2 examples of these numbers so you can kind of get an idea of, like, what are you even talking about? So they start and end with the same digit. That would be something like 33. Starts with the same digit, ends with the same digit, and it's odd. Okay? And that is a, it's got a tens place. It's got a ones place. Okay? We also have a number like 313, where it starts with the same, ends with the same, but it's a 3-digit number. So it's got a hundreds place, a tens place, and a ones place to keep track of. So the first thing we need to do is try to figure out how many 2-digit numbers fit into this scenario that are odd and begin and end with the same digit. And we need to think about our tens and our ones place. If it's odd, you know you only can have the numbers 1, 5, 7. Oh my gosh. You'd think I'd remember 3. 1, 3, 5, 7, and 9 in order for it to be odd. So those are the only number options that you have that can go here or here. So in the tens place, I have 5 different numbers that I can pick from. 1, 3, 5, 7, 9. In the ones place, you'd think you have 5 options, but once you pick the number here, this number also has to be the same. So yes, you have 5 options for 10. So let's say you pick the number 5 for your 10 spot. That means you only have 1 option that can go in your 1 spot, and it's got to be 5. Or let's say you pick the number 3 to go in your 10 spot. You only have one option then, and it's got to be 3, because remember the first and the last digit have to be the same. So you have 5 numbers that you could possibly put in the 10 spot, but you really only have one number that you could put in the 1 spot in order for it to be odd and start and end with the same digit. So 5 times 1 is 5. So there are 5 2-digit numbers that fit this scenario. Only 5 of them. Now we need to figure out how many 3-digit numbers there are. So in your hundreds place, again, you have 5 options, because you can figure out 100, 300, 500, 700, 900. You have 5 options of numbers you can put in the hundreds place. In the ones place, though, again, you only have one option, because once you pick your hundreds place, your ones place has to match it. So there's only one number that can technically go there, because once you pick, like, let's say 7, so it's 700, you know it has to start with the same and end with the same, so this also has to be 7. But then this number here in the tens place can be any number 0 to 9, right? Because you could have 707, 717, 727, 787, 797, and it doesn't matter. And so all the numbers between 0 and 9, there are 10 numbers between 0 and 9. So you have 5 options of numbers for the hundreds place, because you know it's got to be odd. You have 10 options for your tens place, because it doesn't matter about your tens place. It can be whatever number you want it to be. And then you only have one option for your ones place, though, because once you pick your hundreds place, this number has to be the same. So 5 times 10 times 1 gives me 50. So there were 5 2-digit numbers. There were 50 3-digit numbers. And so the answer, how many odd numbers between 10 and 1,000, starting in with the same digit, 50 plus 5 is 55. There are 55 odd numbers between 10 and 1,000 that start and end with the same digit. These are tricky. The next one's even trickier. Get ready. It's the last one. How many license plates of symbols, letters, and digits, so we're thinking letters like the alphabet, and we're thinking digits like numbers, can be made using at least one letter in each? How many license plates of 2 symbols, so a license plate, usually when you think about it, it's got a bunch on the back, but this is saying it's only got 2. How many license plates with 2 symbols on the back of it? So we're thinking letters and we're thinking numbers can be made using at least one letter in each. At least we have to have one letter. So immediately we're thinking, okay, let's say we use letters here. This will be our letters. So for example, we could put A here. How many letters are there in the alphabet? 26. Okay? And then let's say we use digits here. And so I'll use 1. A1. How many digits are there that you could pick from? Well, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 10 of them. So if we multiply using these fundamental counting principles, 260 times, I gave you the answer. 26 times 10 is 260. So there's 260 so far that uses at least one letter in each symbol. So I have letters and digits. However, what happens if I decide to have the letter go second? That's not the same as A1. This is 1A. So again, I just flip-flopped them. I moved the letters, I moved the digits. And so 10 times 26 is another 260. So we have 260 plus 260, and secretly there are more options. There's one more set. So this was using letters and digits. because it said at least one letter in each. At least one. So what if we have 2 letters? What if there aren't any digits? What if we decide, nope, no digits. We're not going to use numbers in this one. We don't feel like it. I'd rather use 2 letters. Makes sense to me. I want this one to be a letter. I want this one to be a letter. I want it to be my initials. There's 26 letters that I could pick from to put in this spot. There's also 26 letters I could pick to put in that spot. 26 times 26 is 676 options. So this one was letter then number. This one was number then letter. And this one was just made of letters. These are all of our options. When you add them together, there are 1,196 license combinations you can have with all of that. How many license plates can you make? 1,196. Here is your homework. We'll go over it tomorrow. Hopefully this makes a little bit of sense. It's just thinking about all of the total options and then multiplying things together to find that maximum number of things that you can make or combinations that you can have. Good luck.